Okay, in this video we'll be talking a bit about intercepts of graphs and how you can use them to graph and make graphing a little easier. So again, we start with some terminology. Solution points of an equation that have 0 as either the x-coordinate or the y-coordinate are called intercepts. These are points at which the graph intersects or touches the x-axis or the y-axis. So for instance, in these examples, where do each of these graphs touch the x-axis or the y-axis? Well, here it touches the y-axis here, 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 and here. It touches the x-axis nowhere here, 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 and here, and here. So here in this picture, the purple circles would be y-intercepts. The green circles would be x-intercepts. Basically, for the bottom line of graphing, these are special points on a graph that are relatively easy to find. So you don't sort of have to try to guess them with the point plotting method. You'll just be able to find them. So how do we find intercepts? The way that we find them is, so for instance, to find x-intercepts, again, this is where the graph touches the x-axis. All you have to do is set y equal to 0 and solve for x. Again, because when it touches the x-axis, what's happening is y is actually hitting 0 at that point. Similarly, to find y-intercepts, that's where the graph touches the y-axis, x, in that case, x would be 0, which means that we can solve for them by setting x equal to 0 and solving for y. So, for example, let's find the intercepts of the graph of y equals x squared minus 4x. And we're going to use these to help sketch the graph as well. So, first, how do we find the intercepts? Well, to find the x-intercept, we go ahead and we say, oh, well, when x is 0, when y is 0, sorry, I keep getting that mixed up. When y equals 0, this helps us find the x-intercept. That is, when y equals 0, what happens? Well, plugging y equals 0 into there, we have 0 equals x squared minus 4x. This is a factoring problem. We can factor out x from here, x minus 4. Doing so, that tells us either x equals 0 or x minus 4 equals 0. Seeing how you can use all this algebra that you've accumulated up to this point. That is either x equals 0 or x equals 4. So that was the x-intercept. What about the y-intercept? For the y-intercept, we have what? For the y-intercept, we have that y equals, so we set x equal to 0, which tells us that y equals 0 squared minus 4 times 0. So y equals 0. So our intercept here would be 0, 0, or 4, 0. Over here, it would just be 0, 0. Well, of course, we expected that because that was already, we saw, was a y-intercept. So, how does this help us graph? Well, if we go over here and we want to graph now, we now know a few points on the graph. That is, we have 0, 0 as a point, and then we also have 4, 0 as a point. 1, 2, 3, 4. Now we have a better idea of which points to pick for our table. Let's pick the points in between and see what happens. Picking the points in between, I'll go ahead and cram those in right here. X and y. We can use the point plotting method, and so we want 1, 2, and 3 to see what happens. Plugging 1 in, we get 1 squared minus 4. 1 minus 4 is going to give us negative 3. Plugging 2 in, 2 squared is 4, minus 4 times 2 is 8, so 4 minus 8 gives negative 4. 3, we get 9 minus 12, which is negative 3. So, in other words, we can shore up this graph 1, 2, 3 by noting that we have here 1, negative 3, negative 4, 1, negative 3, 1, negative 3, 2, negative 4, 3, negative 3. And so again, based on our intuition, it looks like this would be another parabola. So that's one way that you can combine the point plotting method to work with finding intercepts. Now it's time for you to work an example, so go ahead and find the intercepts of the graph of y equals negative x squared minus 5x and use these to help sketch the graph. On the count of 3, I'll reveal the solution. 1, 2, 3. So again here, sorry it's a little rough around the edges right there. It should be nicer, it shouldn't be as weird there. Anywho, here I went ahead and found the intercepts, then I got some points. I noticed that I kind of want to point in between because I want to find the vertex of this. That's what that's called, that high point. And I find if I take the point right in between negative 5 halves, that gives me 6.25. So there you go. For more practice in using intercepts to help in graphing equations, be sure to see page 19 of the textbook and work problems number 3 and 19 through 32. In our next video, we'll talk a bit about symmetry.